Alright, so using these formulas, use geometric formulas, the formulas that we just learned for circles, rectangles, and triangles, thrown into these problems. The formula for calculating the area of the triangle is 1/2 the base times the height. B is the base, h is the height. If the triangle has a base of 10 and a height of 8, what is the area? Well, that's ridiculously easy. It says the base is 10, height is 8, half of 10 is 5, 5 times 8 is 40. Done. Number 2, the formula to find the area of a rhombus, is d1 times d sub 2, where those are the diagonals, divided by 2. If the rhombus has a diagonal of length in 4 and 6, what's the area? So area 4 times 6 divided by 2, it's 24, divided by 2, it's 12. Done. That's more about interpreting what you're reading than it is about doing math. Quite frankly, what I said doesn't make sense. That's what math is, interpreting what you're reading. Composite shapes. Composite shapes means that it's a shape made up of many shapes. If you're trying to find the perimeter of a composite shape, like the one that you see here, it is as simple as finding the perimeter of a rectangle. Now let me explain. If you take the top length, the total length, which is 6 and 6, that represents the total length of the top of this rectangle. So if the top is 12, the bottom is also 12. If you take the height or width of the rectangle, depending on your perspective, it's 7, because you got 3 and 4 make up the left side. That means that the right side has to also make up a total length of 7. So the perimeter is simply 12 plus 12, which is 24, plus 7 plus 7, which is 14, makes the perimeter 38. Number 2, in the figure below, triangle ABC is a square, and CDE is a right triangle. If segment BC is 12, as soon as you read that, put it into the picture. I'm going to do more than that. Since it's a square, that means these are all 12, which now means we know the length of one of the sides of the triangle. DE is 16. What is the perimeter of the combined figure? Let me trace over this. What's the perimeter of the combined figure A, B, C, E, D, and you go back to the beginning, A. So we know most of these. We got 12 and 12 and 12 and 16. We do not count this 12 because it's not part of that perimeter that it's asking for. So if we just add those together, let's just do that real quick. That's going to be 36 plus 16, that's 52. So right now we're at 52, which means those cannot be the answer. If you just wanted to estimate, what could the length of this side over here be? It's going to be bigger than 16, and it's going to be bigger than 12. It's not going to be that much bigger. What did we say that was? 52, I think. So right now we're at 52. So we need to find this other side. This other side's not going to be 100. That eliminates that. We're down with two choices. 72 or 77. This triangle, you can find the length of this side in a couple ways. You can use the Pythagorean theorem, it works wonderfully, or if you recognize this is a special right triangle. This is based upon the 3, 4, 5. If you multiply each of these by 4, and you're going to find the length of this other side, makes that 20. So that means this is 72. To sum up, we knew that each of these sides or 12. We were told this was 16. To find this is 20, use either the Pythagorean theorem or special right triangles. Add up all those numbers, you get 72. All right, in the figure below, triangle BCDE is a square, has an area of 4. Well, if the area of this is 4, that means each of these sides has to be 2, because 2 times 2 is 4. What is the perimeter of triangle ABE? That's this triangle here. If this is a square, all these sides are 2. Since each of these angles are 60, it makes this an equilateral triangle, which means all the sides are the same length. In a separate lesson that we talked about equilateral triangles. If all the angles are the same, all the sides have to be the same. So the perimeter of the triangle was 2 plus 2 plus 2, which is 6. All right, that is the conclusion of set 9. Happy time here. Please do exercise in set 9.